Welcome, my friends, to exercise number 3, complexity. We are asked to find the time complexity of this program. So, I want from you to pause the video, get a paper and pen, and write down this and try to find the complexity of these exercises. Guys, it's very important to work with your own, to solve, to try. But if you are just listening, you will not get a master. You will not be a master, and you will not understand every concept. Please try to solve these exercises because they are very important, and the trying you are making is very important. So, after you're thinking and trying to solve them, I hope you find the complexity, time complexity correct. We will start. So if we took int n equal to 1000, so this 1000 is a constant, and int n we are just declaring a constant here. So it is O of 1. If we go to the next line, we are just printing, hey, your input is, and we just need to print the n. Okay, so here in this line, just printing will result in O of 1 only. System.out.print, I'm doing more stuff with plus, and we are again making the same concept by printing n, which is O of 1. So printing or initializing and declaring variables are O of 1. System.out.print and more, printing n also, and printing this message will result in O of 1. So 1, 2, 3, and 4. O of 4, and which is resulting in O of 1. So this time complexity for this algorithm is just, hello my friends, and welcome to exercise number 4, complexity. Find the time complexity of this method called hello. It's void, it's not returning anything, and took int array as parameter, and do some stuff. Pause the video, think about it, write down in your paper, and let's find out in the next 5 seconds. Well, my friends, again, I hope you try it, because writing down and trying to solve exercises is very important. We see here that int sum equal to 0, we start by this, we are just declaring a variable, so O of 1. Int product also will result in O of 1, okay? Now, we have done this and done this. We entered the loop. So for int I equal to 0, I less than array dot length, I plus plus, and do the stuff. This stuff is equal to O of 1. But when founding an array, it is O of n. And O of array length. O of array length. Okay? So it's very important to understand that when you have an array, we are searching and doing this stuff, which is a constant. We're making just an addition operation. So this addition operation would be repeated from 0 to array length. Example, if the array length is 1 million, it will do this stuff 1 million times. And this, if the array length is 1000, would do this for 1000 times. So depends on the array length. This will result in O of n. Again, there is another loop making I from 0, array.length, and make a product. So this product is O of 1, but O of 1. But this loop will result in O of n, because we are making, consider array.length is an n variable, okay? This is the notation, and this what we mean by n, okay? Array.length is n, so we are making the product here, a product operation from 0 to array length. Again, if we have array length is 1 million, it will do the sum operation 1 million times and the product operation 1 million times. So these two loops, these two operations will depend on the length of the array. So O of n will represent its state. Now, system.out.print ln, we have seen that when printing anything, and these are constants, and some of them are variable defined, so O of 1. Look at this of this method. We have O of 1, O of 1, ON, ON, and O1. What are the highest order of this equation? If we make summation, 1 plus 1 plus n plus n plus 1, we have n to n plus 3. We remove the we have two terms. We took the highest term and we remove the constant from this term. It will result in O of n. So in this case, we are solving every exercise and understanding the time complexity for every question. Always, when you have an array, please pay attention for the initial value and the limiting value or the stop condition. Okay? And the way they increment, because in the next videos and the next exercises, we are gonna learn about a new form and going in deep by making calculations and understanding how the array behavior and how these conditions, the initial condition, the stop condition, and the increment condition would works to and affects the time complexity. So this example, this array, this method and this algorithm will behave in time complexity O of n, depending on the array length, which is, hello, my friends, and welcome to exercise number 5. In this exercise, we are asked to find the time complexity of this algorithm. So this algorithm contains a for loop and a system.out.print message. Please pause the video and think about this question. Solving more exercises by your own is the key of the success and mastering the data structures and algorithms. So through the course, we are going to solve many exercises. I hope you pause the video on every exercise and write down your solution on the paper. Now, back to our exercise number 5. The time complexity of this algorithm. We start by the simple one. There is a loop here and a printing message. We said that the printing message is O of 1 and it is constant. Okay? It's very simple. Now, look at the loop. We have this section, the initial condition, the stopping condition, and the increment condition. Okay, guys? We are going to understand how the loop behaves in order to get the correct time complexity. So, this loop starts from I equal to 1. Okay? I equal to 1. And I less than n. I will consider for demonstration n equal to 8. Okay? And I every time is I times 2. Now, let's start. Think about this loop. We are going to make an iteration table that we have seen before. So, I is equal to 1 at the first stage. Okay? N is equal to 8. And what the input here? System.out.print. Hey, I am busy looking at I value, which is 1. Please concentrate with me, guys. This is the first time, this is the first iteration. Okay? Now, this is executed. Going up, I is increased by 2. So 1 times 2 is equal to 2. So this is 2. Okay? Now, I equal to 2. 2 less than 8. Yes. So go and print again this message, and I equal to 2. Now, going up. Again, I equal the I new is equal to the old new as the old I times 2. So new value of I is equal to 2 times 2. 2 times 2 is equal to 4. N is equal to 8. 4 less than 8? Yes. So go and execute what inside the loop. So I is equal to 4. Now, going up, again, I is equal I, the old I, which is 4, times 2 is equal to 8. 8 less than 8? No. So go and stop. We need I less than or equal 8 to continue. So this will not be executed anymore. Okay? So, what this means to us as executing 3 messages instead of 8. If we don't have I equal I times 2, if we think about I plus plus, then we need to have 8 printings. 8 printings, okay? But here, in I equal the old I times 2, we are jumping. I think about it as 8. So we are, every time we are jumping to 1, 2, 3, 4, 5, 6, 7, and 8. The first time was 1, 2, 4, and 8. And we cannot reach 8. So 1, 2, 4. It is executed 3 times. This number is very important. 3 times is very important. In math, we have n equal to 8. Log 8 is equal to 3. So we have entered n equal to 8, and we executed the message system.out.print 3 times. This means the complexity is executing 3 times. We are executing 3 times this algorithm. So system.out.print is printing this 3 times instead of 8. So log 8 is equal to 3. This means the complexity is equal to O log n. Okay? So log 8 equal to 3, which means this is the time complexity. Hello, my friends, and welcome to exercise number 6. In this exercise, we are asked to find the time complexity of this method. Pause the video and think about this method. Remember, when you see arrays, think about n, but not all the times. We have solved exercise number 5, and we have seen that a for loop, an ordinary for loop, but with the different increment plus plus, and it is I equal I times 2, it will become log n as complexity. And not linear, it is logarithmic. So please pay attention when you see a for loop. Now, let's solve this exercise. We start from here. We have, this is the body of the method. And we have here, let me make it different color. In green, we have this. This is the body of the outer loop. So the outer loop here will be resulting in I equal to 0, it is the initial, and I less than array.length. Remember, array dot length is referred as n. Think about it as n. Okay? So, and the increment is I plus plus. So this array is going through all the elements from 0 to n. This complexity of this loop is O of n. Okay? So this will result in O of n. Now, inside this array, this loop, we have another loop, nested loop, and it starts from j equal to 0 to j less than n, and its increment is j plus plus. So it moves from and goes through all elements from 0 to n, and is printing this. Okay? So this complexity of this array is n, but the complexity of this is O of n. Okay? And the outer loop is O of n. This is O of n, as we have said, that the outer loop, this is the loop, and the green is the inner loop, and in in yellow is O of 1. Okay? So we have the outer loop is moving through all the elements from 0 to n, and the inner loop is executing the code from 0 to n, and the code is system.out.print. This is O of 1 times n times n. So 1, this is the inner, times how many times it is executing, time n. It is executed n times. And this loop, the inner loop in green, is executed n times because it is a nested loop inside a bigger loop, and an outer loop, that it is going from 0 to n elements. So 1 times n times n. This result in n square. So the time complexity of this exercise and this method and this algorithm is O of. Hello, my friends, and welcome to exercise number 7. In this exercise, we are going to find the time complexity of this algorithm. So this algorithm is containing two nested loops. The outer loop, the for, and the inner loop is for, but it prints the system.out print at I and j, printing the values of I and j. Please pause the video and think about this exercise. Solve it on your own on paper. Okay, I think you solved it, and let's try to solve this exercise. So we are dealing with, and this course, or the aim of this course, is to learn you how to think logically and how to think in algorithmic way, and how the algorithms and the complexity works. These exercises are very important for any interview, and even in your subjects or even in your university. I need from you to solve by your own these exercises because they are very important. We start. We have a for loop here. It starts from I equal to 1 and ends at I equal less than or equal to n. Okay, and the type of increment is I plus plus. So these conditions are very important to understand and to determine the type and the time complexity for this for loop and every for loop. So this for loop is being executed n times, okay? Okay? N minus 1 plus 1 is n plus 1. It is executed n plus 1 times, okay? But we have, and we are interested in just getting the highest order of the equation. Moving inside n. This loop, this inner loop, talking about this inner loop, is being executed n times. So it starts from 1 till n. And this is executed n times. Now, this loop contains a system.out.print statement, and it is a constant. But we need to determine the complexity of this loop. It starts from j equal to 1. Please pay attention, guys, with me. j equal to 1 and j less than n, and j, the increment way of j is j times 2. We have solved in exercise number 5 this type of loop, this type of complexity. But I will repeat it. Think about n. I will take n as an example and put it as 8, okay? But let me first say that this would result in O of 1. And this O of n, okay? So n equal to 8. Let me show you. At the first iteration, I, j, and n. N is constant, and it is equal to 8. And we are not interested in I, since it is it will be executed 8 times. We are interested in j. So every time I is increased, j is executed how many times? J starts from 1. Okay, so the first iteration, I will took I equal to 1 and solve about it because we are not interested in I. And since it's I equal to 1, I loop through j and start executing j. So all these terms, I equal to 1 and j will be different. J equal to 1. J less than 8, yes, go and execute this statement. So the result is executing system.out.print the statement, okay? J is increased by 1. No, because j equal j times 2. So j is increased by the product, not by the plus plus. So the new j is equal to the old j, which is 1 times 2. So the new j is equal now to 2. Okay? N is 8 because it's constant, and the result is executing the s system.out.print. Okay? Now, going up, j equal to 1. No, it is increased by j, the old j is 2 here, times 2 is equal to 4. So 4 is j. Starting from j equal to 1 and j, we see the condition. J is 4 and n is equal to 8. So 4 is less than 8. Yes, go and execute the statement. System.out.print. Again, j is increased by times 2. So 4 times 2 is equal to 8. J is equal to 8 now. J less than n? No, it is equal to n. So j is not less than n. So it is stopping here the loop. It will stop here and go up for I and start I again because it is I is increased by plus plus. Remember, when increasing I plus plus, so this loop will go through all elements from 1 till n. But this loop, the inner loop, is not going through all elements from 1 and n because we have the elements from 1 to n is 1, are 1, 2, 3, 4, 5, 6, 7, and 8. Look at this table. J is moving from 1 to 2 to 4 and stops because 8 is not reached. So we have 3 elements. From 8 numbers, we have chosen 3 numbers. This will remember us with log 8 numbers is equal to 3. Go and choose from these 8 numbers 3. This will result in a formula log 8 equal to 3. Therefore, we are choosing from these n numbers the log of them. Therefore, the complexity of this inner loop is O of log n. Because if we give 8 numbers, we are choosing 3 of them. Okay? Therefore, we are executing this statement by 1 times log n times n. So, here, n times log n times 1. Therefore, this result in n log n. So, if we take an example of 8, we have executing I from 1 to 8. We are executing I 8 times, and log 8 is 3 times and times 1. So this will result, log 8, sorry. Log 8 is equal to 3. So 8 times 3 times 1. Okay? If we go and put this algorithm inside the IDE and we run it, we are going to execute this 24 times. We have 24 statements telling us the system.out.print at I and j, for example, anything, okay? Any numbers. So, since we are executing this, we have n log n. Remember, guys, the trick here is that j equal to j times 2, which result in log n. Hello, my friends, and welcome to exercise number 8. In this exercise, we are asked to find the time complexity of this algorithm. So, find the time complexity of this for loop starting from I equal to 1, I less than or equal math dot power 2 of n and I plus plus, and system.out.print this message. Pause the video and think about this exercise, and I hope you write your answer in the comments below to see how the activity and how the participation in this course will affect your progress. Now, solving these exercises are very important to understand all the concepts. So please write them down and try to solve them, and write these exercises on your copybook in order to review them later on when you have an exam or an interview. As every loop, we have to start with the conditions, with the initial condition, with the stop condition, and the incremental condition. This loop is int I equal to 1. So, we will start with 1 here. We will stop at I less than or equal math dot power of 2 and n. This library math, we used the power method from it, and we have passed 2 and power n. This will result in 2 to power n. So if we enter any number n here, or we pass any number n to this loop, it will go through from 1 till 2 to power n. If we pass like 4, if n equal to 4, there is also a condition here. I told you increment is I plus plus. So all the elements from 1 to till 2 power n are going to be passed through this loop. Okay? We have here O of 1. So we have, it is very simple. So this is a constant O of 1. And as I told you, this loop will go through from 1 till 2 to power n, and acting and moving from 1 to 2 and all through all these elements. Okay, let's take an example. N equal to 4. Okay, so what are the elements if n equal to 4? It is these are from 1 to 2 to power 4, which is 2 to power 4, 2, 3, 4, 5, 6, 7, 8, 2 times 2, 4 times 2, 8 times 2, 16. So 2 to power 4 is 16. Okay, so 9, 10, 11, 12, 13, 14, 15, and 16. So this loop will go through all of these elements 16 times, 16 iteration, and printing this system.out.print as 16 times. If we go and took an n equal to 5, this will execute this statement as 2 to power 5. Okay? It is 16 times 2 is equal to 32 times. Okay? If we took n equal to 6, it will give us 2 to power 6. So will result in 64 times. Therefore, the time complexity of this exercise is O of 2n. Okay? It's 2 to power 8. For example, it will execute it 256 times. Okay? So therefore, O equal to 2n, power n. Okay? This is the time complexity. It is the power. Hello, my friends, and welcome to exercise number 9. We are asked to find the time complexity of this for loop and this for algorithm. This for loop is printing a statement, just printing the I, and it is of complexity O of 1. It's very simple. Now, as I told you in the previous videos, we are going to pay attention to the initial values, to the stopping values, and the incremental value. Okay? The way they increment. So, this loop will go through from 1, will start from 1 till fact I is less than or equal factorial of n. This is a method called factorial, and we pass n, and we calculate the factorial of n. So, in mathematics, the factorial of any number is the number times the following number, minus 1, times the number minus 2 till reaching 1. So, for example, if I have like 5 factorial is equal to 5 times 4 times 3 times 2 times 1. So the stopping condition of this is 1. 5 times 4 is 20 times 3 is 60 times 2 is equal to 120. For example, if we took n equal to 5, we are going to go through this loop from 1 till 120, okay, which is 5 factorial. Okay, now I++, this will tell us that we are going to loop through all the elements. We are going to iterate through all the elements of this loop. Okay? And we are going to execute this statement around 120 times. Therefore, if we enter like 6 factorial, we are going to 6 times 5 times 4 times 3 times 2 times 1. So 120 times 6 is 600 and 720. We are going to execute this 720 times. Okay? Therefore, this execution will depend on the factorial of the n. Okay? So, we enter n equal to 6, it will result at 720. We enter 5, n equal to 5, it will result in 120 times execution of this statement. Therefore, this exercise, the complexity of this algorithm is going to execute the print I according to the range from 1 to n factorial. Okay? And this is the trick in this question, making and understanding the n factorial and the algorithms. So the complexity would be O of n factorial. And this is the worst, this is one of the worst algorithms and one of the worst big O notation, which is n factorial. For example, if we put n equal to 8, we are going to execute the statement, this simple statement, 40,320 times. This is n equal to 8. What about n equal to 100 or 1,000, 1,000 or 1 million? This will result in very big numbers, and this causes this algorithms to be a bad algorithm. Hello, my friends, and welcome to exercise number 10. In this exercise, we are asked to find the time complexity of this method. It is print by taking an array in the array as a parameter and having a nested loops to be executing a system that output print by. So, pause the video and think about this exercise, and please write down the solution of this exercise and try to solve it, and list your solution in the comments below. So let's start solving this exercise. Please pay attention. As I told you in all the previous exercises, when you see a for loop, please watch out the initial condition, the stopping condition, and the increment function, and the increment condition. We start by this loop. This loop would be executed. Let me or drawing again. This would be executed from I equal to 0, okay, and I time less than array dot length, and I plus plus. Think about array dot length would be n, okay? We refer array dot length as an n or as n in all the exercises. We start from 0 to n and I plus plus. Therefore, this loop is executing its code from 0 to n, and it is not jumping over the elements. It's executing all the elements of n. Therefore, the outer loop would be of complexity O of n. It's very simple. Now, the inner loop here, we start from j equal to I plus 1. So here we are going to introduce another trick, a new trick inside this, inside the complexity. Okay? So there is a new pattern here introduced. So int j equal to I plus 1 and j less than n and j plus plus. So the inner loop in yellow would be from I plus 1 till n. Okay? This pattern for loop is very common. It's important that you know the runtime and that you deeply understand it. You cannot rely on just memorizing common runtimes. Deep comprehension is important. Okay? So, continuing the iteration, the first time through j runs for n minus 1 step, and the second time it's n minus 2, and then n minus 3 steps, and so on. Therefore, the number of steps is 2 in total. For the first iteration, when you need to solve like these examples, you cannot solve them by understanding and memorizing the common things and the common run times. Okay? You need to make and draw on paper this and try to see the iteration table. For I equal to 0, this is I, this is j. When I equal to 0, j starts from 0 plus 1. So the first time j is 1. I will put n equal to 8. Okay? N is equal to 8. J is 1. This is the result. J is equal to 1. Yes, 1 less than 8. Okay, go and print by. Okay. The second iteration in J would start from 2. And so on. Printing hereby and hereby and so on. Okay. From 1 to till reaching 7, because 8 is 7 less than 8, but 8 is not less than 8. And stopping here for the first iteration of is I. Again, going up, increasing I by 1, it's now 1. Now J here is equal to 1 plus 1, starts from 2. This time it starts from 2. So I equal to 1, j equal to 2, and n it is a constant by here. It will result 2, 3, 4 till 7. And so on. So if we took 2, j will go from 3 and to 7. So I will put here the result. If we go from I start from I equal to 0, j will start from 1 and stops at 7. It will, if we go from I equal to 1, j will go from 2 to 7. I from 3 to 7. If we took 3, j will go from 4 to 7. Here from 4, 5 to 7. 5, it will go from 6 to 7, and 6, it will go from 7 to 7. It is 7, it will be executing one time. And if we go from 7, j will not execute. Okay? Okay? So here we have how many times this have been executing. Number of times we print by. Okay? We execute the system.out.print. Here we have 7 times. Okay? Here we have 6. 5, yes, or no. It is here 5, sorry. 7 is included. Yes, 1, 2, 3, 4, 5, 6, and 7. 3, 4, 5, 6, and 7. This executed 4 times, 3, 2, and 1. Okay? Like these exercises are very important because you need to get the pattern. You need to understand the pattern. The sum of of 1 through n minus 1, this is n minus 1 because n is equal to 7 and j executed to n minus 1. This is n minus 1. 7 in j represent n minus 1 and 7 in I represent like n. Okay? Now, n, how many times these are executed? think about it. Alternatively, we can figure out the runtime by thinking about what the code means. It iterates through each pairs of values I and j, where j is bigger than I. There are n squared total pairs. Okay. In an ordinary nested loops, where I equal to 0 and I less than n and j equal to 0 and j less than n, we are executing n square, which is for, in this case, n square, which is, if we took n equal to 8, so we have 8 digits here and 8 digits here. Okay, we have 64 times. But now, in our case, we are not executing the whole thing. We are executing the part of this. So let's clarify again. If we have like n square, when pair equal to n equal to 8, we have here these are the pairs. We have 8 columns and 8 rows. Okay? 1, 2, 3, 4, 5, 6, 7, and 8. Sorry. So we will start from here. If we have n square, we are going to go through all of these digits. Okay? Okay? But since we have this type of algorithm, we start from I equal to 0. Think about I as here, as iterating through here. And we start from I equal to 0 and j equal to 1. So we will occupy this. Okay? We will start from this. I redraw it with for a better understanding. So let's start with I here, I for the rows and j for the columns. If I and j are starting from 0 and till n, so we should like color all of these cells. But since we are following a different pattern, we start from I equal to 0. This is I equal to 0. And this is I equal to 0 and j equal to 1. So this cell is not filled. So we are going to fill this. For I equal to 0, we are going to execute 7 times the system.out to print. So all of these from 1 till 7 are being executed. So this is 0, 1, 2, 3, 4, 5, 6, and 7. All of these would be colored, and these are executed carefully. All of this, but the first cell is not executed. If we move into I equal to 1, 3, 4, 5, 6, and 7. If we move into I equal to 1, j is executed from 2 till 7. So the first 2 cells are being empty, and we are going to execute from cell I equal to 1 and cell j equal to 2. So from here we start, we execute all of these, okay? And these are being executed, okay? It's very simple. Now, we move into 2, I equal to 2. J is executed starting from 3. It's very simple. And we move through all of these. I equal to 3. We move from 4 and we start executing from 4. Okay? It's very simple. Okay, guys, you need to master this algorithm by understanding how you are writing and from where you start and when you end and the way you increment this. When I equal to 5 or 4, j is starting from 5. It's very simple. When I equal to 5, j is increased executed from 6 and till 7. When I is equal to 6, j is executed only one time because j is equal to 7. When I equal to 7, j is not executed anytime. So this is a very different from executing a nested loop where the complexity of it n for the outer loop and the inner loop is n. Since here we are following a different pattern. If O of n square is executed in this condition, we are going to color all of these cells in the table. But here we are doing a very different pattern. These are only that we have colored are being executed. So we are following a pattern here. We are following a pattern where I equal to 0, j is equal to 1. So always j is incremented by 1, is increased by 1 in all the cases and over I. Okay? This looks like half of this matrix is being executed, which has size roughly n squared over 2. Okay? So if we color all of this matrix, we could result in n squared. But this matrix is half of it is executed, so we need to multiply by half. Okay, so half of this matrix is being executed. Therefore, it takes O of n squared time. So the average work. We know that the outer loop runs n times. How much work does the inner loop do? It varies across the iteration, but we can think about the average iteration. What is the value, the average of the value of 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10? The average value would be in the middle. So it is roughly 5. Okay? We took an example about 8. And it is roughly 4. What about 1, 2, 3 till n? So the average value of this sequence is n over 2. So therefore, according to this matrix, according to this drawing, according to the iteration, we are executing half of this matrix. So the complexity of the inner loop is n over 2. So the complexity of the inner loop is O of n over 2. Okay? Because we are executing half of the code. Okay? We are executing half of the code that we should use. Okay? Because I equal to 0 every time it is increased. And j is increased by 1. So this would result in the matrix here. Like this matrix, it's 64 cells. If we get n equal to 8, then we have 64 cells. And we are executing half of these cells, which is 32 times printing the system that output print by. So we are printing 32 times the by here. Okay? If we execute this. But since we have n above, we need to multiply n times n over 2 times O of 1. Therefore, we have that the final complexity is n times n minus 1 over 2 and O of n squared. Okay? It's very simple. And one important thing that I should remember you that n minus 1, because we are summing the integers of 1 through n and on runtime. Okay, so we are getting from 1 to n minus 1 because here we are looping. Hello, my friends, and welcome to exercise number 11. We are asked to find the time complexity of this method. So this function is print hello, taking into parameters two arrays, two integer arrays, array 1 and array A, and array B, the second array. And we have inside it two loops, nested loops, okay? And printing hello. I want from you to pause the video, write down the solution, and check it later on when we start solving and compare your progress in the time complexity and big O notation. Know that solving like these exercises will help you master this subject in your university and crack the interview. Okay, so let's begin solving. We have here the void print hello array. We don't take care about this. That we have here the for loop. The first for loop is starting from I equal to 0 and stopping at array a dot length and a plus plus. So we have solved many exercises about this. This will result in executing the code inside the outer loop from I equal to 0 till array a dot length. Array a dot length, I denote it by a. And since we have I plus plus, so we are going to go through all elements from 0 to a. Okay? The array a length, I will suppose that a equal to 20. Now, let's go to the inner loop. The inner loop starts from j equal to 0, stops at j less than array b dot length. Note that the trick in this question is that we have different array length. So array A is maybe would be the length of it less than or equal or greater than array B dot length. And we are going to go through all the elements from 0, this array, from 0 to, denote by B is the length of array B. Okay, and this is O of 1. So, guys, I will suppose that B is 30 and A equal to 20. If we think about this for a while, if we have 20 times here, because the array length is equal to 20, and array B is 30. So every time we have iteration here above, every time I is increased, J or this loop will going to print hello 30 times. Okay? And we have above, we have 20 iterations. So every iteration in outer loop, it will result in 30 iteration in the inner loop. This will, if we execute this, execute this algorithm inside IDE, we will get 20 times for the I iteration times 30, because every time I is executed, there is 30 times executing and printing hello. We will get 600 times saying hello. system.out.print hello. We have 600 hello. Okay? I need from you to think about it. What would be the time complexity? If I just before I tell you the notation, in order to solve all the exercises of these time complexity or space complexity, please go and take example on and change the numbers in order to get the sequence, how this algorithm behaves. So if I took A equal to 100 and B is equal to 5, okay? This will result, we are going to loop through the outer loop 100, and in each iteration, we are going to print 5 hello. So the algorithm here will execute A times B, which 100 times 5 equal to 500 hello. So we are going to see 500 hello if we change A to 100 and B to 5. Therefore, the complexity of this program is O A times B. Okay? This is the trick in this question. I like this question because when you see nested loops, many people think about it as n square. And in this case, it's not n square. It is, or a square. It is AB because every loop has its specific condition, its specific limiting, and specific way and behavior. So the pattern of the loop will detect the correct. Well, hello, my friends, and welcome to exercise number 12. We are going to solve the time complexity of the function print high. So in this function, we have print high taking into a parameter the int array A and int array B. And we have 3 loops inside, and they are nested. And we are going to print high in the K loop. I need from you to think about this algorithm. Please pause the video and write down the solution. Try to solve this question because solving exercises is very important. So I think and I hope you get the correct question answer. We start. The print high, so we don't take care about the header. We take care about the loop here. We have the first loop starting, as I told you, we get the initial conditions, the stopping condition, and the behavior and how the increment of the iteration works. It is I++, so we are going to go through all the elements from 0 to array A length. Okay, so the first loop, the outer loop, will go through from all elements from 0 to A. I denote A by the array A length, okay? And we are going to go through all the elements, so it is O of A. Now, in the inner loop, it is here. This will go through all elements from j equal to 0 to j less than b dot length. And the way of increment is j++. Okay? So b is the array b dot length. We have solved this in the previous exercise. Okay? And I told you the trick in that question in exercise number 11 is understanding that array A dot length is different than array B dot length. Okay? If they are equal, they would be O of n squared. Okay? And we have here another loop called K. This is the loop K. It starts from K equal to 0 to K less than 100,000. And the way of increment of K is plus plus. So it is going to loop through all the elements from 0 to 1,000 to 100,000 loop or iteration. And we are going to print high. It is O of 1. If we calculate how many times this high or this statement would be executed and displaying high, we will result in, we start from 1 times how many times this statement would be executed if we execute the 4K loop, the 4K, times 100,000, okay? Times how many times the J loop would be executed. It depends on the array B length, okay? So times B. Times how many times this J loop would be executed according to the I condition. And I will stop at array A dot length. So array A dot length, it will go through from 0 to A, and it will be executed A times. Okay? So the final result would be 100,000 B times A high message. Okay? Or displaying high. Okay? Therefore, we have 100,000 B times A. If B equal to 1 and A equal to 1, it would be executed 100,000. If B equal to 10 and A equal to 1, it would be executed 1,000,000 times. So we depend on executing this on the value of B and A. But this is a one term. And in big O notation, we don't care about the constant. We don't care about the constant that it is multiplied by the input, by the variable input. The variable input here is the array A dot length and array B dot length. But 100,000 is a constant. And we know every time that it would be executed 100,000. Because since it is a high number, but it is a constant, we don't care about it. We care about only studying B times A, because this is variable. This depends on the array A length and array B length. Okay? Therefore, the final result and the solution would be O of A times B. This is the time. Hello, my friends, and welcome to exercise number 13. We are asked to find the complexity of is prime method. It is of Boolean returning type, and it took in parameters int n. So we have a for loop, and the starting condition from x equal to 2 and the stopping condition at x less than or equal to square root of n and x plus plus. Pause the video and think about this algorithm. I hope you write down and solve this question. And more exercises as you solve, as you practice more, you will get a master. You will be a master in data structure and algorithm, because solving more exercises will be making you better thinking, better thinker, better problem solver. Okay? And these questions are, by the way, from interviews and real interviews. Okay. I want from you to recall that if we have x plus plus here, so we have all elements, we are going to go all through all elements from 2 to less than square root of n. So these elements, this loop will go through all the elements from 2 till square root of n. So the square root of n is radical n. This is a function that calculates the square root of n. Okay? If n modulo x, this is x, equal to 0, then return false. This is O of 1 returning, and this one is O of 1, and return true is O of 1. So that determined the algorithm is on the initial condition and the stopping condition and the way of increment of a loop. So the loop here will determine the algorithm time complexity. Let's take an example of taking n equal to 16. Okay. Now, let's solve this exercise. We start from x equal to 2, and x less than square root of n, radical n. Let me make this. I put x here and here. And let's try to solve this iteration. Always when you want to solve like these exercises and get the pattern, take an example. Okay, we took an example n equal to 16. We start the iteration. At the first iteration, x equal to 2. X less than square root of n. Square root of n would be equal to 4. Okay, so the square root of n is 4. Okay. 2 less than 4, yes. So go and execute this method. It would be making the calculations. Okay. Now it finishes here. Increase x by 1, going up. 3 is x now, and the square root of 16 is 4. So 3 less than 4, yeah, or equal to 4, yes. Go and execute. It goes here. And going up above, it will go up to here and start making the conditions. 4, comparing the conditions. 4, now x equal to 4, and x 4 less than or equal to 4, yes, because square root of 16 is 4, and 4 less than or equal to 4, yes. So go and execute this. Now it goes here and going up. X is increased by 1, so x is now 5. 5 is less than or equal to 4, no, so it will be stopped. Now, when putting like this table, we see the pattern, how many times it would be executed. It being executed like 3 times. Okay, so 3 times. But the limiting behavior, we are going to go through from 2, 3, and 4. So all the elements are being executed from x. This is the range from x to radical n. Okay? And x would be from 2 to radical n. Okay? This is the range. If n equal to 25, it would be executed. How many times? It would be executed 5 times or 5 times, yes. Because radical 25 is equal to 5. It would be 2, 3, 4, and 5. Okay? Sorry, 4 times. So it is increasing according to the radical n. Okay? And it starts from 2. So radical n is the stopping behavior, and it is the limiting. And since we are going to through and loop through all the elements till finding the radical n, the time complexity of executing this algorithm is O of radical n. Okay? This is the limiting behavior. This is the time complexity. This is the stopping condition of this algorithm at the radical n. So always take 2 examples in order to get the pattern, in order to get the mathematical sequence that the algorithm. Hello, my friends, and welcome to exercise number 14. We are asked to find the time complexity of the method factorial. It is returning type is integer, and it has a parameter int n. So pause the video and think about this for 10 seconds and write down the solution on a paper and comment it in the comments below. So I am waiting your comments, and I hope you solve it and you understand the algorithm and how to solve these time and complexity questions. So let's begin. In the above, we have if, else, if, and else. As we said in the general rules of the big O notation, we took the worst one in the if conditions. So if, else, if, else, if, and else. We are having three possibilities, or 3 switches: if, else, if, and else. 3 cases. So we took the worst one. We start studying with the first one. If n less than 0, it's comparing return -1. It is O of 1 because nothing is doing. Nothing is done here with a complex or depending on the input. Here, else if n equal to 1, return 1. Also, it is O of 1 because there is no interference or dependence on the input that we have. Else, return n times a factorial n minus 1. This is a straight recursion. We will learn about recursion in the next videos, so don't worry. This is the recursion. This is the calling of the function again, going up here and call the function again and again. But here we are passing n minus 1. Okay, so every time it is decreased by 1. And here it is n times factorial n minus 1. This is depending on the n value. So if we pass factorial of 5, return 5 times factorial of 4. So this will depend on the n value. Let's take an example if we pass n equal to 5. So n equal to 5. This will result if n less than 0, no. Else if n equal to 1, no. Else return n, return, this is the return, the first statement, 5, which is n, times factorial, go and call factorial of 4. So again, it go and execute this. Factorial of 4 would be n less than 0, no. Equal to 1, no. Else n equal to return n times factorial. So it will return 4 times factorial of 3. Factorial of 3, it will go up again, make check with less than 0, equal to 0 to 1, or or else return n times factorial of 2. So 3 times factorial of 2. Again, 3 times factorial of 2. 2 factorial of 2 less than 0, no. Else if equal to 1, no. Return 2 times factorial of 1. If it is here, it is 2 times factorial of 1. Factorial of 1 going up, less than 0, no. Equal to 1, yes, so return 1. So factorial of 1 is 1. And this is the recursion. We will see this in the next videos in more and more details. So don't worry. Just understand this exercise. Now, 1 is substituted by here. 1. So 2 times the 1 is equal to 2. Now, 2 is again executed and substituted here. So 3 times 2 is equal to 6. Factorial of 3 is equal to 6. So 6 is executed, substituted here. 6 times 4 is equal to 24. Okay? Factorial of 4, this is the factorial of 4. Factorial of 4 is executed here. So return 5 times factorial of 4, which is 120, I think. Yes, it is 120. Okay, it's very simple. So we return 120. If we pass n equal to 5, the value of this function or the returning value, it will return 120. So it depends on the factorial of n. But since it is a straightforward recursion, it is depending on the n. Okay, so it will result in O. Hello, my friends, and welcome to exercise number 16. In this exercise, we are going to find the complexity of this function, all fib. Okay, so this function, all fib, contains a loop, a for loop, and this loop will print out I and the Fibonacci of it. So fib I, it will go and call the method. And this method fib, we have seen it in the previous video. So pause the video and think about solving this exercise and getting the correct time complexity of it. Please note what you solve, what you will gain, what you will understand better. So as you more practice, as the more you become a master in data structure and algorithm, and even on all coding related topics. Okay, so let's begin. If we start with void all fib, we have a loop, and here the loop, as I told you and as we have solved before, when you see a loop, look at the initial condition, the stopping condition, and the way of increment. The way of increment plus plus, this means that all that we are going to go through all the elements from 0 to n. So we are going to execute this statement n times. So from 0 to n, and the way of increment plus plus, so it is O of n. Okay? But we are calling a function. And calling a function depends on the function algorithm, the function complexity itself, okay? So we need to calculate the function time complexity in order to get the correct time complexity of this algorithm. When you see Fibonacci, put in mind that we have an exponential, okay? So we have solved this before. And we said that Fibonacci f of n minus 1 and Fibonacci of n minus 2, this will result in O of 2n. Please go back to exercise number 15 to better understand this function. Okay? But the trick here in this question, it is not just calling the function. We are inside a loop calling every time this function. So here we have n times, so we are going to call the function n times, and the function complexity is 2n. Therefore, the complexity of this is n times 2 to power n. Remember, guys, you were not asked to get a common complexity, a very simple complexity like 2n, n factorial, n square. You are asked in the interview or the exam in university to solve complex things and compound complexities. Okay, so n times 2 to power n is the solution of this exercise because Fibonacci will act as 2 to power n. And we have seen it in the exercise number 15. Okay, we took an example. Let me show you. If we took an example n equal to 5, okay? N equal to 5. All fib will execute it to 5. It will loop through 5 times from 0 to 5, okay? And we call the function fib and pass 5, okay? We have seen fib 5 in the previous video. It is equal to 5, sorry. Okay, so Fibonacci of 5 is equal to the Fibonacci of 5 is equal to 5. This will result in 5. Okay, and we are going to execute I. So 0, 1, 2, 3, 4, and to 4. So 4 will be giving as for us as 5. Okay, so the fourth element in Fibonacci or the fifth element would be 5. So 5 Fibonacci is equal to 5. Okay, therefore, since we are depending on the n here, the n of the loop, and the n in the Fibonacci, we have 2n for Fibonacci and n for the loop. Multiplying them by together will result n times 2 to power. Hello, my friends, and welcome to exercise number 17. In this exercise, we are asked to find the time complexity of this function. So this function will give us the product of two numbers. It took in a parameter int a and parameter int b, and it will return the result as sum, which is type of int. Pause the video and think about this function and how to get the time complexity. Please write them down on the paper and try to solve it and comment it in the comments below in order to see your progress and your motivation to solve these exercises. So let's begin. I hope you find the best answer and the correct answer. In sum of equal to 0, we have it O of 1. For int I equal to 0, we have a loop. So I told you that we need to start with the initial condition, study the stopping condition and the way of increment. It will go through all elements because I++, and it will go from 0 to b. So it from 0 to b, okay, it will go through the elements from 0 to b. And it depends on the value of b, okay? Sum equal to the new sum equal to the old sum plus a, okay? So this is executing only one, okay? And now it will return the sum. Return the sum is O of 1. O of from 0 to b, and all the way through all the elements would be a result from going through from 0 to b. So it is O of b. This would be a result in 1 plus O of B plus O of 1. Okay? What is the higher solution? What is the higher order? It is of type B. Therefore, the time complexity of this function is O of B. Why we are doing this? In order to tell you that not always depend on n like n and the value of n. And here we are depending on b. So always try to study the initial, the stopping, and the way of increment of all of these exercises. Okay? In the loop. Please, when you see a loop, please study the initial, the stop. Hello, my friends, and welcome to exercise number 18 in time complexity. So, we are asking to find the time complexity of this function called mod. It took 2 parameters, int a and int b, and find the modulus of the division between them a modulo b. Okay, so a modulo b would be the result of this mod function. Okay, pause the video and think about this. What is the time complexity? As you solve more questions and exercises, as you advance in the career and advance your algorithm and problem solving skills. So I hope you solve this and comment it in the comments below. Let's try to solve it. If b less than or equal to 0, we have to return -1. Okay, there is no else block for this. I told you in the general concepts that if else and the conditional statements, we took the worst one between them. Okay? If b less than 0, to return -1. No dependency on the input, so it would be O of 1. Int division, we are declaring a variable div equal to a less than b. Or sorry, a divided by b. So this would result in a constant operation of O of 1. We are just dividing a over b. Okay? And we are declaring a variable div a slash b. Now, return a minus div times b. This would be result in O of 1 because we are not depending on anything. Okay, we are just making an operation, like subtraction operation and product operation of constants. Okay, so a and b, a here minus div times b will return the modulus. This is O of 1, O of 1, and O of 1. This will result in O of 1. Okay, it's very simple question, but it is an interview question. So we should mention it, and we should cover all of these results, all of these big O notation in order to get ready and crack the big. Hello, my friends, and welcome to exercise number 19. We are asked to find the time complexity of this function. It's called div. Took 2 parameters a and b, and we are going to calculate the division. So we start. Before we start, please try to pause the video and try to solve this exercise by your own on paper and comment your answer in the comments below. Waiting your questions and answers. Okay, so let's begin. We start int count equal to 0. This declaration is O of 1. Int sum equal to b, O of 1. Okay? So this loop, while sum less than or equal to a, we are getting sum less than or equal to a. Sum equal to the old sum plus b. This declaration is equal to O of 1. And count, we are increasing 1 by 1. So we are going to go through the values from b, because sum equal to b, to a or less than a. So this loop will go through all elements, because plus plus count would be plus plus from 0. Okay, b equal to sum. Okay, so we are going to go through from b to a and through all the elements. Okay, and return count. But there is something here. Sum is equal to the old sum plus b. Okay, so the sum is going to be multiplied by or the b plus sum. Okay, if you don't understand, let's go and get a take an example here. Let me show you. Div int a. Let me take a. Where is the cursor? A equal to 10 and b equal to 2. Int count equal to 0, so count is equal now to 0. Count equal to 0. And sum is equal to b. It is equal to 2. So while sum less than or equal to a, sum less than 10, yes. So go and execute this. Sum now is equal to the old sum plus b. Sum is 2 plus b is 2. So sum is equal to 4. Now increase count by 1. 0, it would become 1. Again, sum less than or equal to 2, less than or equal to 10, yes, because sum equal to 4. So it is less than 10 or equal to 10. The old sum is equal to the new sum, which is, the new sum is equal to the old sum, which is 4 plus 2. b equal to 2. It is equal to 6. Count is increased by 1. It is becoming 2. Now, sum is equal to 6. Going up, 6 less than or equal to 10. Yes, go and again. And sum, the new sum is equal to 6 plus 2 is equal to 8. Count equal to 3 now. Going up, sum is equal to 8. Less than or equal to 10? Yes. So sum, now sum, the new sum equal to 8 plus 2 is equal to 10. Go count is equal to 4. Going up, sum less than or equal 10. Sum is 10. Less than or equal 10? Yes. So go and execute this. Sum is equal to 10 plus 2 equal to 12. So count, increase it by 1 equal to 5. Going up, sum is 12. Less than or equal 10? No. So go and stop here. Return the count. Count, we have 5. Okay? Now, what is the time complexity? Think about it. We have divided 10 over b, which is 2. And we have made 5 iterations. If we took a equal to 12, we will make 6 iterations. Okay? According to 12 and b equal to 2. It will result in 6. If we took a equal to 14 and b equal to 2, it will result in 7. So, please try to find the sequence. As I told you, time complexity, these questions is related to the examples that you took. So always took an example to see and solve the algorithm, a pattern. So when a equal to 10, b is equal and 2, b 2, let me try to put here, a, b, and the result of it. How many counts? 5. When we have 12 and b equal to 2, it will result in 6 counts. 14 and 2, it will result in 7. So we have noticed that A over B will result in the count. Therefore, the time complexity of this question is O of A over B. So always when you think about complexity, time complexity, take more than example and try to find the sequence that this algorithm follows. So this pattern is dividing A over B. Hello, my friends, and welcome to exercise number 20. We are asked to find the time complexity of the square root function. It took a perimeter int n and calculate the square root of this number. Okay? So I want from you to pause the video and think about it, how to solve this exercise and how to find the time complexity. I hope you solve it correctly. Please write your solution in the comments below before we continue. So let's start. We have a for loop and a return statement. For int guess equal to 1. This is the initial condition. Guess times guess less than or equal to n. This is the final or the stopping condition. And guess plus plus is the increment function or increment condition. Okay? Inside the loop, there is an ordinary if statement and checking just guess times guess, which is guess square, equal to n, return guess. This is O of 1. And return minus 1 is O of 1. Okay? So the for loop here will determine the complexity of this function. Let me take an example here in order to better understand and then calculate the complexity. Guess will start from 1 till guess square less than or equal to n. And it is plus plus, it's going to pass through all the elements from 1 till guess square. Okay? Now, let's start by taking n equal to 5. N equal to 5. For int guess equal to 1, guess square less than or equal to 1, and guess plus plus. Okay? We start from 1. This is the iteration. N, guess, and the result. N, the first iteration, n equal to 1. Guess times guess, 1. This is guess square. Guess square is equal to 1 because we started from 1. And n equal to 5, sorry. Sorry, guys. It's n equal to 5. So, guess square less than 5, yes. It will go and execute this. If guess square equal to n, return guess. Otherwise, it will not do anything. So it will not do anything. Again, goes up, n still equal to 5. Guess square, guess is increased by 1. Now guess is equal to 2. 2 times 2 is equal to 4. So guess square is equal to 4. 4 less than 5, yes. It goes here. Guess square equal to n, return guess. No, it is not the case. So we have 4 equal to 5, no. So it will not execute anything. Here, it will increase guess by 1, going up. N equal to 5. Guess now equal to 3. 3 square is equal to 9. So 9 less than or equal to 5? No, so it will stop the loop. It will break outside the loop and it will return minus 1. Now, what we have done here, it will execute 2 times. if n equal to 5. Okay? If n equal to 6, it would execute. Let me show you. If n equal to 6, and g square would be starting from 1, 4, 9, 16. Okay, because 4 square is equal to 16. It would execute 4 times. Okay, so when n equal to 5, it is executed 2 times. When n equal to 6, it is executing 3 times. Okay, now if n equal to 7, it would execute like about 4 times. So what is the relation? We are executing and we are looping this from 1 till radical n. It is on the radical n because we are getting the square root of guess square, and it is less than n. So it's very simple. Guess square equal to n. G equal radical n. We are moving from 1 to radical n, or radical n, or it is from 1 to g. Okay? It's very simple. We have solved this. It is O of radical n because we are not depending on g, we are depending on n. And we need to get n. So in order to get n, we need to make n equal g square. Okay, so we have the stopping condition is g square less than or equal to n. So n would result in g radical n equal to g. Okay. Hello, my friends, and welcome to exercise number 21. In this exercise, we are asked to find the time complexity of the function sum digits. So this function, it took in a parameter int n and returned the sum. So what is the sum? It is the sum of the digits, how many digits in the number that you entered, and so it will calculate the log. So log 100 is 2 because we have 2 digits after the 1, because 100 divided by 10 is 10. So it is 2 digits after the division. Okay, so let's start solving. So pause the video and please try to solve this by your own and comment your solution. I hope you solve this question and you know it. Okay, waiting your comments. We start int sum equal to 0. This is O of 1. Okay, return sum O of 1. The while loop here will determine the complexity of this question. Int or n greater than 0, while n greater than 0, we have sum equal to the old sum plus n modulo 10. So we are dividing n, the entered n, by 10, and now the new n will be divided by 10. So every time this loop, the sum will add the old sum plus n modulo 10, and n is divided every time by 10. So, as I told you, to solve all these questions, you need to take an example. Take n equal to 100. Okay? So, I will make a table here. N is 100 at the first iteration. It is greater than 0. Yes. So as the sum is equal to 0. Okay? During the first iteration, the sum is, this is the first iteration, iteration I. There is no iteration, this is initial. at the first iteration, n, or the sum, becomes the old sum. Sum is equal to the old sum plus n modulo 10. So the old sum is 0 because we have initialized this as 0, plus n modulo 10. 100 divided by 10 is 10, and there is no remainder. So n modulo 10 is 0. Okay? So 0 plus 0, sum is 0. Okay? Now n is divided by 10. So this is equal to n equal to the old n divided by 10. So 100 divided by 10 is 10. Okay, this is the first iteration. The second iteration, going up, n is greater than 0? Yes. So 10 greater than 0. Go and make again the code. Execute this code. Sum is equal, the old sum is equal to the new sum is equal to the old sum plus n modulo 10. Old sum is 0, okay? 0. Plus n modulo 10. n is 10. 10 modulo 10 is equal to 0 because 10 divided by 10 is 1. There is no remainder, so it is also 0. Okay? It is 0. So the sum is 0. n is divided again by 10, so it is 1. Going up, n, it is 1. Yes, so the third iteration, n becomes 1. 1 greater than 0, yes. The sum is equal. Sum new is equal to this s old plus n modulo 10. S old is 0, okay? Because it's 0. Plus n modulo 10. 1 modulo 10 is 1 because 1 is not divided by 10. Okay? And the modulo, it becomes 1. So the sum is equal to 1. n modulo 10, divided by 10. So 1 divided by 10 is equal to 0.1. And since it is an int here, int n, so we took only the real part, the integer part. N becomes 0. Going to the fourth iteration, going up. N greater than 0? No, it is equal to 0. So it stops the iteration. Okay? And return sum. So sum will be returning like 1. And the value here is becoming like log 100 is equal to 2. So we have 2 digits. Okay? We have 2 digits. So every number here could have up to its digits. So n equal or d is the digits equal to log n. So the complexity of this program is